Right now, at this exact moment, there is a world out there, a real, physical world, drifting alone in the darkness at the edge of our solar system. It has mountains, 3 kilometers high, built not from rock, but from water ice. So frozen, it behaves like solid steel. It has glaciers that flow, not made of water, but of liquid nitrogen, creeping across a landscape no human eye has ever seen in person. It has an atmosphere, thin, gasping, collapsing, and rebuilding itself every few centuries, like a planet drawing slow, labored breaths. And underneath its surface, scientists believe there may be a hidden ocean, a liquid sea, buried under miles of ice, in temperatures that would kill you in under a second. This world is real, it is there, and in 2006, a committee of scientists in Prague voted to erase it from the official map of our solar system. They stripped it of its name. They stripped it of its status. They called it a dwarf. Its name is Pluto, and this is its chapter. Let's start where most stories end. August 24th, 2006. Prague, Czech Republic. The General Assembly of the International Astronomical Union, the IA, had been in session for 2 weeks. Nearly 2,500 astronomers from 75 countries had gathered, and on that final day, they voted. 424 votes in favor, 78 opposed. Pluto was demoted. Now, here's what the textbooks don't tell you. Only 424 of those 2,500 astronomers actually voted. That's less than 18% of the total delegates. The majority had already left Prague before the final ballot was called. Many of the world's most prominent planetary scientists were not in that room. Alan Stern, the principal investigator of NASA's New Horizons mission, the only spacecraft ever sent directly to Pluto, called the vote, quote, an embarrassment to astronomy. He has never accepted the decision. Neither have hundreds of his colleagues. This wasn't a clean scientific verdict. It was a contested ruling, and it changed how an entire generation of children learned about our solar system. But to understand why it happened, we need to go back further, much further. It's 1929. Flagstaff, Arizona. Lowell Observatory sits on a mesa called Mars Hill, named not for the planet, but for the man who funded it. Percival Lowell, a Boston Brahmin, a wealthy, eccentric, a man who spent years convinced he could see canals on Mars, built by an intelligent civilization. Lowell died in 1916, but before he did, he predicted something. He believed mathematical irregularities in the orbits of Uranus and Neptune pointed to a hidden gravitational source, a 9th planet. He called it Planet X. His prediction turned out to be wrong for the right reason. The mass he calculated didn't match, but it sent astronomers searching anyway. Into this story steps Clyde Tombaugh, 22 years old, a Kansas farm boy who had built his own telescopes from spare tractor parts and scrap metal. He had never attended university. The Lowell Observatory hired him specifically because he was cheap and because he was willing to do the kind of work no seasoned astronomer wanted, staring at photographic plates for hours, day after day, looking for something that moved. The technique was called blink comparison. 2 photographs of the same region of sky, taken days apart, were loaded into a machine called a blink comparator. The machine would rapidly alternate between the 2 images. Stars impossibly distant would not shift position, but something close enough to our sun, something orbiting within our solar system, would show a tiny displacement, a flicker, a ghost. On February 18, 1930, after nearly a year of searching, examining over 90 photographic plates, each containing up to 50,000 star images, Clyde Tombaugh saw the flicker, a tiny dot, shifted position, beyond Neptune, 14 to 15 astronomical units further from the sun than any known planet. He found it at 4 o'clock in the afternoon. He sat alone with the discovery for 45 minutes before telling anyone. He was 24 years old. Before we go further, we want to hear from you. Here's the moral dilemma at the heart of this story. Clyde Tombaugh spent years of his life discovering Pluto. He died in 1997, 9 years before scientists voted to demote it. Some of his ashes are aboard the New Horizons spacecraft, flying past the world he found. He never got to see it up close, and he never got to defend its status. Was it ethical for the IAU to remove Pluto's planetary status without requiring unanimous scientific consensus, and without giving the public a voice in a decision that reshaped how an entire generation understands our solar system. Drop your verdict in the comments. We read every single one. This is Dark Chapter, and we don't do easy answers. The discovery of Pluto was announced on March 13, 1930, the birthday of Percival Lowell, the man who never lived to see his prediction pay off. The question of naming fell to the Lowell Observatory. Suggestions poured in from around the world. Minerva, Kronos, Zeals. But the name that won came from an 11-year-old girl in Oxford, England, Venetia Burney, daughter of an academic family, an avid reader of mythology. Over breakfast, her grandfather read her the morning newspaper about the newly discovered world. Dark, distant, almost lightless. She suggested Pluto, god of the underworld in Roman mythology, ruler of the realm where sunlight never reached. Her grandfather passed the suggestion to his colleague, Herbert Hall Turner, a professor of astronomy at Oxford. Turner cabled it to Lowell Observatory. The astronomers voted. Pluto won unanimously. Venetia Burney lived to see new horizons fly past the world she named. She was 90 years old. She died in 2009. Her name is now carved permanently into space science. The Venetia Burney Student Dust Counter, aboard New Horizons, an instrument measuring dust particles in the outer solar system, is named in her honor. An 11-year-old named a planet. A room full of scientists in Prague, unnamed. It's 76 years later. So what exactly did the IAU decide? In 2006, the Union formally defined a planet for the first time in history. 3 criteria. All 3 must be met. 1. The object must orbit the Sun. Pluto does this check. 2. The object must have sufficient mass that its own gravity pulls it into a roughly spherical shape. Pluto does this check. 3. The object must have cleared the neighborhood of its orbital path. This is where Pluto fails, and spectacularly so. Pluto orbits within a region called the Kuiper Belt, a massive disk of icy debris extending from Neptune's orbit outward to roughly 50 astronomical units from the Sun. The Kuiper Belt contains hundreds of thousands of objects. Many are similar in composition to Pluto. Some are nearly its size. Eris, discovered in 2005, is actually slightly more massive than Pluto. By IAU's definition, Pluto hasn't gravitationally dominated its neighborhood the way Earth or Jupiter have. It shares its orbital zone with countless other bodies. The technical term for what Pluto now is a dwarf planet, one of at least 5 recognized dwarf planets, alongside Eris, Haumea, Makemake, and Ceres. But here is the scientific counterargument that never went away. The clearing the neighborhood criterion is scale-dependent. If Earth were relocated to Pluto's orbit, it too would fail to clear that enormous region of space. By the IAU's own logic, Earth in Pluto's position would be a dwarf planet. This is not a fringe theory. It is a published mathematical argument. Geophysicist Kirby Runyon of Johns Hopkins University and a team of 6 authors proposed an alternative definition in 2017. Any object massive enough to achieve hydrostatic equilibrium, a round shape held by its own gravity, should be classified as a planet. Under that definition, our solar system has over 100 planets. The debate is not over. The chapter is not closed. Whatever you call it, planet, dwarf, planet, Plutoid, what Pluto actually is demands serious attention. Let's establish the physics. Pluto is 5.9 billion kilometers from Earth on average, at the speed of light, 299,792 kilometers per second. A radio signal takes over 5.5 hours to reach it. When New Horizons sent its data back from closest approach, scientists waited 4 hours and 2 minutes just to receive confirmation that the flyby had worked. The surface temperature hovers between -218 and -240 degrees Celsius. To put that in physical terms, at that temperature, nitrogen, a gas that makes up 78% of the air you're breathing right now, freezes solid. Oxygen would freeze. Carbon dioxide would freeze. Even the chemistry of life as we understand it becomes geometrically impossible. Pluto's diameter is 2,376.6 kilometers. Our moon is 3,474 kilometers in diameter. Pluto is smaller than our moon. 6. Plutos placed side by side would not span the width of Earth. 1 Plutonian year. One complete orbit around the Sun takes 247.9 Earth years. The last time Pluto was in the same position in its orbit as it is today. The American Revolution had not yet happened. A single day on Pluto lasts 6.4 Earth days. The Sun, viewed from Pluto's surface, would appear roughly 1,000 times dimmer than it does on Earth. It would look like a very bright star, bright enough to read by, but barely. And Pluto has moons, 5 of them. The largest Charon is so large relative to Pluto that the two bodies are technically a binary system. They orbit a gravitational center point that exists in the space between them, not inside Pluto itself. Charon's diameter is 1,212 kilometers. It is 51% the size of Pluto. No other known moon-size ratio in the solar system comes close. The remaining 4 moons, Nix, Kerberos, and Styx, are small, irregularly shaped, and were all discovered after 2005 using the Hubble Space Telescope, July 14, 2015, 7:49 a.m. Eastern Time. New Horizons makes its closest approach, 12,500 kilometers above the surface, traveling at 14.5 kilometers per second, moving so fast that pointing its cameras required engineers to pre-program every orientation, too, within fractions of a degree, because at that speed, there was no time for real-time corrections. The images began arriving, and the science teams at the Johns Hopkins Applied Physics Laboratory fell silent. Pluto had a heart, a massive, bright plane in the shape of a heart, roughly 1,600 kilometers across, large enough to contain the state of Texas twice over, pale white against the reddish-brown terrain. It is officially named Tombaugh Regio, named for Clyde, the left lobe of the heart. The brighter portion is called Sputnik Planitia. It is a nitrogen ice basin, almost perfectly flat, roughly 3 kilometers below the surrounding terrain. Scientists believe it formed from an impact billions of years ago and has since filled with nitrogen ice that slowly convects, meaning it circulates in slow motion, cycling from bottom to top over hundreds of thousands of years. Sputnik Planitia is geologically young. Its surface contains almost no impact craters, which in planetary science is the primary indicator of age. No craters means the surface is constantly being reshaped. Something is actively repaving it. This was not supposed to be possible on a world this cold, this small, this far from the sun. Pluto is geologically alive. Pluto has an atmosphere. This alone should stop you. A world smaller than our moon, at the frozen edge of the solar system, with surface temperatures that freeze nitrogen solid, and it maintains a thin veil of gas around itself. The atmosphere is primarily nitrogen, with traces of methane and carbon monoxide. Its surface pressure is roughly 10 microbars, about 100,000 times thinner than Earth's atmosphere. But it is there, measurable, dynamic. Here is what makes it deeply strange. Pluto's orbit is highly elliptical, more so than any other major body in the solar system. At its closest point to the Sun, it reaches 29.7 astronomical units. At its farthest, it retreats to 49.3 astronomical units. That's a variation of nearly 20 astronomical units, almost 3 billion kilometers, in the same orbit. As Pluto approaches the Sun, its surface ices warm and sublimate, converting directly from solid to gas. The atmosphere thickens. As Pluto retreats, those gases refreeze and fall back to the surface as snow. The atmosphere is currently collapsing. Pluto passed its perihelion, its closest point to the Sun, in 1989. It is now moving further away. Within the next century, much of its nitrogen atmosphere will freeze out entirely. Pluto breathes on a timescale of centuries. There is also the matter of Pluto's color. Most people assume a frozen world would appear white or gray. Pluto is reddish-brown. The color comes from organic molecules called tholins. When ultraviolet radiation from the sun strikes methane in Pluto's upper atmosphere, it triggers photochemical reactions that produce complex carbon-based compounds. These tholins rain down onto the surface and accumulate, painting Pluto in hues of rust and amber. Tholins have been detected across the outer solar system. They may also exist on Titan, Saturn's largest moon, a world scientists increasingly consider one of the most likely places in the solar system to host complex chemistry, perhaps even rudimentary life. Here is a question that keeps planetary scientists up at night. If we discovered microbial life beneath Pluto's surface, in a theorized subsurface ocean kept liquid by radioactive decay in the planet's core, would that life retroactively change how the IA classifies Pluto? Should the presence of life be a criterion for or is the classification purely a matter of physics, and life is irrelevant to the question of what a planet is? This is Dark Chapter. Leave your argument below. Not just your answer, your reasoning. The best comment gets pinned. Let's examine what may be the most consequential finding in Pluto science. The leading hypothesis for the formation of Tombaugh Regio's left lobe, Sputnik Planitia, is that a massive impactor struck Pluto early in the solar system's history, gouging out a deep basin. The impact concentrated mass in that region. Here is the anomaly. Sputnik Planitia faces directly toward Charon. Always. This is not a coincidence. Tidal forces between Pluto and Charon would naturally reorient any large mass concentration toward the tidal axis. The fact that the basin is locked in this position suggests it is underlain by a significant mass. A subsurface ocean would provide that mass. In 2016, a team led by Francis Nimmo at the University of California, Santa Cruz published research suggesting a subsurface liquid water ocean, possibly 100 kilometers deep, could exist beneath Pluto's icy crust. The heat source would be radiogenic, the slow decay of radioactive isotopes in Pluto's rocky core, which generates thermal energy even billions of years after formation. This is not speculation for speculation's sake. We already know this mechanism works elsewhere. Europa, Jupiter's moon, almost certainly has a subsurface ocean powered partly by tidal flexing. Enceladus, Saturn's moon, actively vents water vapor from subsurface, sees through cracks in its ice shell. Ganymede, Titan, possibly even Ceres. The deep sea of Earth's own oceans harbors life at hydrothermal vents, communities of organisms that have never seen sunlight, that run entirely on chemosynthesis, converting chemical energy from volcanic outgassing into biological fuel. If Pluto's core is still warm enough to maintain liquid water, the implications are extraordinary, not just for Pluto. For every cold, dark, icy world we have dismissed as dead, the universe may be far more alive than we imagined, and the most alive places in it may be the ones we have never thought to look. New Horizons, launched on January 19, 2006. From Cape Canaveral, aboard an Atlas V rocket with a solid-fuel upper stage that gave it the highest Earth departure velocity of any spacecraft ever launched. It left Earth at 58,536 kilometers per hour, faster than any human-made object had ever traveled at that point. It still took 9.5 years to reach Pluto. Let that land, the fastest machine humans have ever built, moving at nearly 50 times the speed of a rifle bullet. And it took almost a decade to cross the distance, to keep costs down and systems alive across that journey. New Horizons was placed into electronic hibernation for over 2/3 of the mission. It would wake periodically, phone home, the signal taking 4.5 hours one way, confirm it was functional, and go back to sleep. On December 6, 2014, it was awakened for the final time. The encounter sequence began. Every instrument calibrated, every camera aligned. The principal investigator, Alan Stern, later described the team's emotional state during closest approach as controlled chaos. Over 50 people in the Mission Operations Center. Data arriving 4.5 hours after it was collected Any problem that occurred during the flyby would not be known for hours, and there was nothing they could do about it anyway. New Horizons survived perfectly, returned over 6.25 gigabytes of data, images, with a resolution of roughly 80 meters per pixel, at closest approach, detailed, enough to see features the size of a city block on a world 5 billion kilometers away. What it revealed shattered every expectation. Towering water-iced mountains, some exceeding 3,500 meters in height. Smooth, nitrogenous plains, blade-like methane ice formations, called bladed terrain, or informally Tartarus dorsa. Eerily knife-like ridges stretching for hundreds of kilometers. Possible cryovolcanism, volcanoes that erupt, not lava, but water ice slurry and nitrogen gas. A world that should have been geologically dead for billions of years, preserved in a cosmic freezer. Instead, geologically active, dynamic, strange, alive in its own way. So where does Pluto stand today? It orbits. It breathes. Its heart pulses in slow nitrogen convection. Its mountains stand. Its hidden ocean waits, possibly beneath the ice. The debate over its status never truly ended. In 2017, a team of 6 planetary scientists from institutions including NASA's Ames Research Center, Johns Hopkins, and the Lunar and Planetary Institute published a formal scientific argument that the EO's geophysical definition is flawed, that the clearing the neighborhood criterion is physically incoherent at scale, that Pluto and over 100 other bodies should be reclassified as planets. The IAU has not reversed its decision, but it has not silenced its critics either. And in 2023, NASA announced preliminary studies for a potential Pluto orbiter mission, a spacecraft that would not merely fly past Pluto, but enter its orbit, spend years there, map it completely, possibly even probe beneath its ice. No mission has been funded, no launch date exists, but the conversation is happening. Clyde Tombaugh's ashes continue their journey past the Kuiper Belt into interstellar space, aboard the spacecraft that finally revealed the world he found. Venetia Bernice name travels with it, and Pluto keeps its orbit, indifferent to the committees, indifferent to the votes, unmoved by the definitions that humans construct and then demolish. It is what it is. A world dark, cold, beautiful, and stranger than anything we imagined. That is what this chapter was always about. Not the demotion, not the bureaucracy of science, but the reminder that the universe does not ask for our permission to be extraordinary. This has been Dark Chapter. If this episode challenged how you think about the boundaries of science, not just the science of planets, but the science of how we define what matters, share it with someone who still thinks Pluto's demotion was settled, because nothing in Dark Chapter is ever truly settled. New episodes drop every week. Subscribe, turn on notifications, and leave us the one word you'd use to describe Pluto in the comments below. One word. That's all. Let's see what this community is made of. This is Dark Chapter. Stay curious, stay skeptical, and never let anyone tell you the story is over.